Hello everyone, I just wanted to offer a quick supplement to the lecture on LEF, DEF, and LIB files. So here you can see I have my terminal pulled up and I'm going to be looking through the OpenRoad flow scripts repository. We'll talk about this later, but this is a repository that orchestrates OpenRoad into a full flow. But importantly, it has some open source technology libraries and processes that are available. So I'm going to just look at the file itself and show you some of the details that we were looking at in slide form. So first I'm going to open up the LEF file for the NAND gate 45 process. And so here, jumping back to the top, you can see, there's some copyright information. All of this is commented, but then you can just start seeing some of the information that we talked about in this LEF file. So this is exactly what OpenRoad is reading when it reads in this LEF file. So there's some version information, some other sort of header information, but you can see that there's the database units that we have here. There's a manufacturing grid. There's a bunch of layers, so we actually have some extras related to the polysilicon, the active area. Not super useful in this context, but then you can see we have all of our Metal 1 details. So we have the type, the spacing, width, pitch, direction, all of that. We also have some extra values in here that aren't super important. These are actually related to parasitics. It tells you what is the capacitance, what is the thickness of things. That's actually not used very much, except in very old processes. So this information is not very useful. It's just sort of filtered out and replaced by more accurate values later. But continuing on, you can see that we have our VIA layer. You can see that we have our Metal 2, and it just goes on from there. We've got VIA 2, Metal 3, and it just sort of continues going all the way until the end of the file. And so down here you can see we have our site information. So here is where the cell site is defined, and you can see that has the symmetry in the Y. It's a core class. Here's the size, and then just scrolling up back a little bit, we also have some VIA array information here. So it tells you if you want to generate an array of VIAs, how do those get spaced and how do they get implemented. So if we now go to the macro LEF file, then we can see also what's stored in here. So again, the header, some of the same information, but now we have these macro definitions. So remember that these are going to be master cells in ODB, and you can see some of the properties that we talked about, the class core, we talked about the origin, symmetry, which cell site does this have, and that is appearing in the technology file. Some of the antenna information, which is sort of beyond the scope of what we'll talk about, but you can see the pins that are defined here, which are, in this case, these are the terminals, and the actual shapes, which would be the pins, are then defined later on down here. So this is an AND gate. This is a different type of AND gate with a different driving strength, so it has a different amount of current that it can supply. So several different sizes here, and if we just kind of search through for maybe just the macros, so we can see sort of all of the different cells that are defined here. You can see there's AND 3 gates, so those are 3 input AND gates. You can see that there's other kinds of gates that we haven't talked about, like an AOI is an AND OR and then inverted, which turns out to be a useful gate in many different logic synthesis applications. For certain types of structures, they end up being used a lot, so they're appearing in here. Same with AOI, or then we have our buffer cells. So these are just 2 inverters integrated together into the same cell. And so those are very frequently used for rebuffering signals, making sure that signals can go fast and get across the chip quickly. And so then let's see, from here we have a whole bunch of other gates in here, and if you go to the bottom of the file, you end the library, and the last cell we have is the XOR 2. So that's all that's going to be in this file. And so thanks. I just wanted to give you a quick view of, if you actually look into the file, what do things look like. So that's it for this sort of extra supplement, and I'll see you in the next lecture.